In this lesson, we will discuss other methods of proving triangles congruent. This is section 4-5 in your textbook. The essential question for this lesson is, what are two other ways to prove triangles congruent? We presently have three ways to prove triangles congruent. These were postulates that told us that if we have side, 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 we can prove triangles congruent. If we have side, angle, side, we can prove them congruent. And if we have angle, side, angle, we can prove them congruent. So three postulates, three methods for proving triangles congruent. Now this first additional method of proving triangles congruent is going to be a theorem. It's theorem 4-3. It is called the A-A-S Theorem. This theorem states, if two angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. All right. First of all, let's look at what we're saying here. First of all, we're saying two angles, okay? Now, the key word here is non-included side. Okay, what do we mean by that? Well, remember, in our postulates, we had angle, side, angle, where the side was between the two angles, okay? Here, we have two angles, but the side is not between the two angles, okay? It's only common to one of those angles. So that's why we refer to this as the A-A-S Theorem. So if two angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So now we have four methods for proving triangles congruent, three postulates in this new theorem, theorem 4-3. So how would we go about proving this? Let's assume we've got two triangles, and we'll say that angle A is congruent to angle X, and angle C is congruent to angle Z. And then in terms of sides, you've got AB is congruent to XY. Well, if A and X are equal, and if C and Z are equal, then we can prove that angles B and Y have to be equal. So angle B has to equal angle Y. All right? And if B is equal to Y, we can prove these two triangles congruent by angle, side, angle. Okay? Because we've got the angle A and X, we've got the angle B and Y, and then we have the side between them, AB and XY. So therefore, we have proved this theorem. Our next method of proving triangles congruent is theorem 4-4. It is referred to as the HL theorem. Now, one thing that's important here is this theorem only applies to right triangles. And when it says HL, basically what is it saying? It's saying hypotenuse leg, okay? So this is only for right triangles. Now, this theorem in words says, if the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. Okay? Well, let's look again at this in a little more detail. Okay? We're talking about the hypotenuse. Okay? Remember, the hypotenuse of a right triangle is the side opposite the right angle. A leg is any of the other two sides. So basically what it's saying is you've got two sides of a right triangle. You've got the hypotenuse, and you've got a leg, okay? Now, obviously you know an angle, you know the right angle. So in reality, you've got three parts of the right triangle. So let's look at two right triangles here. So let's assume that the hypotenuses are congruent and one of the legs. That is sufficient to prove these two right triangles congruent. Now notice, this actually is SSA or ASS, depending on how you look at it. Now, remember I said that that didn't apply for proving triangles congruent. The only place it does apply is when the angle is a right angle, okay? So if you've got a right angle, then you can use this theorem to prove triangles congruent. So now we have 5 ways to prove triangles congruent. We have 3 postulates which relate to all triangles. We have 1 theorem which relates to all triangles, angle, angle, side. And we have 1 theorem which relates only to right triangles. Now I would like you to do classroom exercises numbers 1 through 9 on page 142 and post your answers in the drop box. There are a number of triangles, and they ask you whether or not you can prove them congruent and how you can prove them congruent. Thank you.